How's it going there, guys? Day 4, Cocos2d-x game. So, we left off with our player movement, game layer, menu layer, and we were going to pick up by adding the bad guys in the game, so the enemies in the game. So let's go ahead and do that. Just so you can see the game that's running right now. That's where we're at. And if you weren't here before, you can pull the source code for this off of GitHub. And the link for my GitHub, if you can't see it in the browser window, you can get it off my homepage on Twitch. Cool. So let's go to Visual Studio. So I went ahead and added a header file called baddie and a class file called baddie, so we can start implementing our bad guy. Sounds good. So let's go ahead and add a little bit to this header file, get the bad guy started. So we need to include, I'm sorry, I need to go to the header file, not the bad guy file. Just going to close everything down here and clean it up. We don't need that right now. We don't need that. We don't need this. And we don't need this. Okay, cool. So bad guy.h. Let's go ahead and include. So we almost always include our resource header. That just contains, constants to resource files. Cannot open resource. I think I pluraled it. Okay. And also we need core.h. Almost always include core.h. That includes, that's our kind of our singleton instance that contains running properties in the game. So like, for instance, the player's position, the player's current color, and all that good stuff. And we need to reference that for the bad guy to behave properly. Let's go ahead. We'll do our using namespace for Cocos2d. And we reference Cocos2d, I believe, in core header, core resources. So that's why I'm using the namespace here. Let's go ahead and create our class. So just simply baddie, and he's going to inherit the sprite class in Cocos2d-x. So this will give him the ability to, or us the ability now to set animation, set his frames, which are going to be, the animated sprites to make the baddie appear and look like something on the game layer. And it'll also allow us to move his position around too. We can get his position, set his position. So he's going to have movement just like the player's going to have. His movement's going to be a little bit different though. It's going to be predicated on the player's movement and behavior, right? Because he's going to be attacking the player. So it's not that we move the baddie. The baddie will have some AI. So we're going to have to build that stuff in. So let's go ahead and add a private and a public section in our class file. So definitely we're going to need to add some stuff here for the bad guy. And so for hit detection, we're going to need his radius. So let's just default it to a radius of 0 for now, but obviously that will change once we instantiate him and initialize him properly. Similar to our player, we're going to define a color of none by default, but obviously he's going to have a color at some point once he's initialized. And remember the mechanics of this game. So the mechanics of the game are the player will randomly switch between 3 colors, red, green, and blue. And the bad guys are going to appear now, and they're going to appear with one of those random colors as well. Now, if the bad guy's color is the same as the player's color, then the player can attack the bad guy. Now, if the bad guy has a different color than the player, then the bad guy is going to be the one who's on offense attacking the player. And then remember, the player, every 12 seconds, we just randomly change his color. So all of a sudden, you know, he can now be the predator towards other bad guys on the screen that are of his color. So, you know, the dynamics of the game change every 12 seconds. So let's go ahead and bring in our core instance as well. Remember, we referenced core. Core contains all of our magic settings as the game is running. So we use shared core. That's just our singleton call to get an instance of this core. And we also want to add a simple Boolean just to, it's kind of like what we did with the player yesterday. And what we did is, until you actually click somewhere in the game area, the player isn't moving. And the same idea goes with the bad guy. He may or may not be moving based on, you know, certain properties in the game. So we'll tackle that. That's fine. So we're going to extend. So what I'm doing here is I'm overriding some properties on the base class sprite. So that would be init. We also want to override update. And remember, the update is something in our game loop. So as we iterate through every frame, update will be called. So virtual void update. Let's go ahead and add a move method. So the move method is going to take a float as well, which is our difference in time as the frames progress. And we'll just have a simple method called prepare, where I'll just throw in sort of the initialization stuff. I guess I could put that in init, but we'll try to separate things out a bit. We'll create our constructor and our destructor. And let's go ahead and we'll add a getter, a property to get our radius. So the radius, so for our hit detection, we'll also add a property to get and set his color. So just like the player, the bad guy can change colors. The difference between the bad guy changing colors, though, and the good guy changing colors is the bad guy is just going to change color once when he's first initialized and added onto our game area. He'll have a color predetermined and set. Okay, bool get moving. This is just simply wrapping that private underscore is moving variable, and then we'll add a method called trigger is moving. This will kind of kick off the movement for the bad guy. And we should also add some Cocos2d-x actions. So the cool thing about Cocos2d-x is we can create these cool actions so we don't have to code it. Let me just go back. Maybe Gitbook. So, yeah, this thing's so painful. Player sound. Let's just go back and we can quickly look at, so animations. Animations are great. We've done that with the player, but we want to just quickly look at some actions here. Event dispatcher. Maybe I need to go back. We're close. There we go. So by and to, what is the difference? So these are actually actions. Maybe I'll go back a bit, kind of jumping ahead. So actions are objects that are just like they sound. They make a node, and node is actually the, I wonder if I can increase the size of this. Let's zoom in a bit so you guys can see the window. Sweet. So actions are performed against the node base class. Now, if we go back to our baddie class, it extends sprite, but if we F12 to drill down, it extends node. So node is kind of the root class. Well, there's ref is kind of the root class in Cocos2d-x, but in our case, for any sort of game object we're going to use, node is the base class. So just quickly going back to this action, we can just apply actions to any node, any object that's of the base class node in Cocos2d-x. So all of our sprites we can add an action to. So we're going to go ahead and create some actions such as move to. Simply create it. You got to say what's the duration of the action, and the move to expects a target to move to. So in this case, it's going to be a point on our game area that's 50 across and 10 high. Okay. So just using the quadrant in our game area, like 0, 0 starts in the bottom left-hand corner. So 50 is going to be 50 pixels across and 10 pixels high. Anyway, we're going to create some actions. So there's move to, move by, but we're going to do a move to. We'll also do one that creates some cool animations on the bad guy. So let me start adding. So action interval. So this is kind of an interval where there's a repeat going on with an action. So it's a repeating action. So we'll just call it get repeat action. And finite time action. So that's an action that you would specify a time. So that move to action we quickly looked at here on the previous page, if we drill down, it would have a finite time action as a base class, because there's a finite time in this action, right? You're saying it's 2 seconds to move to this point. So that's a finite time. It's not an infinite action. But we'll dig into that and add it. So we'll just call it get move action. Perfect. Everything looks good. Let's go ahead and add these to our class. So all we've done here is define this stuff in our header file, but we haven't implemented these functions in our class file. So I'll just let Visual Studio do the heavy lifting of implementing these functions, and then we'll jump into them and add some code. I don't know if this is any quicker than me copying and pasting, but it's done. Good. So let's jump to our implementation of the baddie, this class file. So now we've got to add a little bit into here. So let's go ahead and work our way down. Bad guy constructor, let's just have him call the init method. And then we can go to, let's go to our init method, and let's do a little bit of magic in here. So let's go this init with frame name. I'll show you what this is going to do in a second. So on last week when we first created this game from scratch, in our core implementation, in our init method in the core, this, remember core, that gets loaded right at the very start of the game. So all of this magic has already occurred before we even touch the bad guy. But what we did is we loaded the sprite sheet, and that sprite sheet, it contains our bad guys. See these goofy looking cells here? These are going to represent our bad guy. So all we're saying is pull out from the sprite sheet the sprite with the tag or the name cell_blue1. So we're just initializing our baddie sprite with an actual sprite in the sprite sheet. And the reason why we want to do that right off the bat is because a bit is going to go on. Obviously, we're going to apply the texture, right? This little image is just considered a texture. We're going to apply the texture to our bad guy class. But as well, it'll define things like his dimensions, right? His height and width based on that sprite as well. So we're kind of initializing this bad guy with some important stuff. But we're going to change that stuff as we continue on with kind of initializing this bad guy. So let's set visible to false because we don't need him to render on the screen right now. All we need to do is initialize him with some dimensions based on that sprite. And we always return true from the init methods. If you return false, then that means an error occurred and Cocos2d-x won't be happy. So good. So we've got our init method. Let's work our way down. Let's do some of the simple ones. Let's go to get is moving. Let's set the let's work with this is moving. We can also work with the colors, but let's get these. Is moving simply returns back our private variable is moving. Okay, and set color. That's going to set our private variable color with whatever is passed. We better give this a name, color. And then our get color isn't going to return an empty color. It's going to actually return our stored private variable color. And get radius will do the same thing. Did we just name it radius? Radius. If I can type. Good. So get radius returns that. Get moving, trigger is moving, repeat action, get move action. So let's go ahead and start doing some of the heavier stuff here. So let's create our actions. So this is more core Cocos2d-x stuff here. We're just simply going to work purely with actions. So let's do our get repeat action. So let's create our action interval that we're going to return back. So that's just going to be the variable that holds our action, and we'll return it. Now we got to add the guts to create this action in between. So what we can do is let's go ahead and we're going to create a scale by action. So what this action is going to do, it's going to repeat continuously until we destroy this bad guy. But anyway, we're just going to scale, like make him grow slightly. And then what I'm going to do is I'm going to actually reverse this action. It's kind of cool. You can create these actions that, in this case, our sprite is going to scale slightly. And then I'm going to reverse the action and it will shrink. So it'll look like this bad guy is kind of like breathing or throbbing a little bit. So let's go ahead and do that. So it's a pointer to our scale action. And pretty much everything in Cocos2d-x has a create method. So let's go ahead and create this action. So we want the duration and the scale. So if you can see this constructor overload, we need a time frame. So we'll say 2.5 seconds, and it's going to scale by 1.3 over that 2.5 seconds. So that's all this is doing. This is going to be an action we can run on this bad guy, and he's going to scale about 1.3 factors, so just, you know, a third bigger over the course of 2.5 seconds. And then let's go ahead and invert that or reverse this, and we'll just use his base class, action interval, and we'll just call it reverse. And since we've already defined scale, let's go ahead and apply the reverse. This is pretty cool. Once we create the action, we can just call reverse to do the exact opposite. So it's kind of cool too, like with movement, you could make him kind of lunge forward and then reverse it to make him come back to his origin. If we wanted to, we're not going to do that, but let's just quickly look. I'm going to F12 into the scale by class, and we should see the base of action interval. So the base class of scale by is action interval. So that's why I was able to go scale reverse, which just returns almost a copy of this scale action, but it's reversed, and we can push it into a variable of the type action interval. So now let's munge those two actions together in a repeat forever action. So it's kind of cool, like these actions, can be grouped together inside of another action interval, and that's what we're doing here. We're saying create another action interval and push on scale by, and then push on after that this reverse action interval. So what's going to happen is we're going to create a repeat forever action, and again everything uses create, and all we do is create a sequence. So what this sequence is doing is saying make it sequential, make action 1, whatever the first action we pass into this create, make it run first, then the next action, make it run right after the first action completes. And so that's a sequence. But then what we're doing is this sequence, we're passing into a repeat forever, so it loops. So all this repeat forever is saying just keep looping that sequence. Keep going and going. And so let's look at this create. You can see the ellipsis, the 3 dots in this constructor argument. It's just saying we can add as many actions inside of this sequence as we want, and they'll run sequentially. And obviously the first, based on the order of you adding them in this create method. So the first action we want to run is scale. As soon as scale is done, we want to reverse it. And then we pass in null to say no more actions are coming in. Sweet. So what's going on? So we've got this repeating action that's going to go on forever. We're going to make him scale up in 2.5 seconds to become 1.3 factor bigger. And then we reverse that to kind of shrink him back down to his original size, because we're just reversing this. So now he'll go back to his original size. And then a null saying there's no more. And it's not saying there's no more actions. It's just saying there's no more actions inside of this sequence. So the sequence has these 2 actions, and we repeat forever. So he'll grow and shrink for eternity. And so we've got this. Let's just go ahead and return that. And that's it. That's all it takes. Now we've got this action for him to grow and shrink forever and ever. And all we need to do is soon we'll have to run the action on that sprite. And we just say run action. And we'll add this in another location. We don't want to run the action right away. We're just getting these actions ready to run. So let's go ahead and create our move action. This one's a little more important. It's going to allow him to move towards the player. So hold on, I'm just going to have some coffee. Okay. So again, what we should do first is when this is called, we can say we had this private variable on our bad guy, and he defaults to is moving as false. We'll just set it to true. So as soon as we actually trigger this action, he's going to be moving. So let's go ahead and we need a speed. We need to define a speed for the bad guy. So I'll just go ahead and create a float. We'll call it whatever. This will be kind of like 4.0. Yeah, let's give this a shot. And it's totally adjustable. We'll just throw out some constants like that speed and see how it works. So let's create a finite action. So it means it's not going to repeat forever. This is going to move. So move to create. And let's just look at the argument. So we need a duration. So how quickly is this move to going to occur, right? Just like with this scale by, it said, you know, we're going to scale him 1.3 bigger, but over the duration of 2.5 seconds. So in our case, he's going to move to this position that we're going to add in a second over the course of 4 seconds. So we could actually reduce this to, let's say, 2 seconds, and he'll move a lot quicker. But we'll give it a shot. So where do we want to move him to? Well, we've got the core instance defined. We want to move him to the player's previous position is fine because we're not storing his current position. But the previous position, as we learned the other day, is simply a small fraction away from where he is because it's the previous frame's position. So we're going to move to that position. And we'll return, remember our sequence, just like we did in the previous. But this sequence has nothing but one simple action, which is our move. So this action is just going to have him move somewhat quickly towards the player's position. Yeah, that sounds good. So we'll do that. Now what should we do? Let's work on, let's have a look at, so we got a knit done. Let's do the destructor. Since we added these actions, we should actually use our director. So get instance. And get instance has a get action manager. The get action manager actually has a handle to all the actions that Cocos2d-x has created. So what we can do is remove all actions from target. And we'll just pass in this, which is the bad guy instance class. And remember, he extended sprite. So we just want to say when we destroy this bad guy out of memory, we want to make sure before we completely release him from memory, we're going to remove any actions that are applied on him. The reason why we do this is because the actions can continually run, right? Like that infinite action we had down here. This guy, we want to destroy that action because that's going to take some overhead on the computer. Okay, so we'll destroy it. Now we should probably look at our trigger moving. So trigger is moving. So trigger is moving. We'll just set that to false for now. Not too sure how I want to do this yet. So let's go ahead. We're going to need to add something to core. Const auto baddies. I'm going to create a vector inside of core, like a container that stores our bad guys. So since we're going to be adding multiple bad guys to the game, we should have them inside of a container so we can access them at any time. So let's go ahead and have a look at core. Let's go ahead and have a look at core.h, and let's go ahead and add our vector. Oh, perfect. I'm including it. So remember, vector is in the standard namespace, so we std into that. And vector uses a generic type, so we got to pass in the type that we hold. And since the bad guy class derives from the base class sprite, we can just kind of cast down to a sprite and store the bad guys in here. that'll just initialize it. That's just a C++11 feature. So we'll just initialize our vector. And we need to wrap that in a getter. So let's go ahead and add a getter. And we return back the vector as a constant to anybody calling it, because we don't want them to change it. We just want them to have a look at it. So std vector is the return type. It contains sprite pointers, and we'll call this method get baddies. So we'll wait for our little green squiggly to show up and our little thing to add this to the implementation. So now we're in core. So now let's add the baddies. All it's simply doing is returning this. So that's all we needed to do. So now we get the bad guys. Obviously there's nobody in there now, but we're going to start popping them onto this vector when we work with the game layer code. So let's go back to here. Let's go ahead and work this. So let's loop through our vector. So we'll do a for loop, but what we'll do, instead of kind of a traditional for loop, we'll work with an iterator. So containers in C++ allow us to work with what's called an iterator. So we're going to get the begin point. So the iterator is really just kind of this, you know, it's almost like, you know, let's say you're reading a book, and you know how like people sometimes put a ruler underneath each line they're on, just so they can tell what line they're reading from. Similar kind of idea. So if we're reading the first line of a page in a book, our ruler is on the first line. And that's where begin returns. It moves that ruler to that first line, which would be our first element inside of the baddies vector. And then what we want to do is we want to move that ruler one line at a time until we get to the end of the page. So let's make sure it, our iterator, is not equal to the end of the page. So baddies, so our vector will have an end method. And end says this is the end of the vector. There's no more elements stored. There's no more bad guys in this vector. Similar idea. It's like the ruler is at the end of the page. There's no more lines to move to. So we're going to iterate until we get to the end of the vector. And finally, in your for loop is the incrementer. We're just going to increment our iterator. So all this plus plus is doing is saying, okay, we're getting the beginning element in your vector, and we'll iterate on every iteration of the loop, and we'll move it one element forward so we can get the next element. So all we need to do in here is we'll define a variable sprite star, since that's what is stored in the vector. It contains sprite pointers, and we'll just call it baddie. And we'll dereference that iterator so that we get what's inside of that iterator back, which is the sprite instance, which is our bad guy. And then what we need to do is we need to check. So this method here, we're going to use it to put the bad guy on the game layer and then run those different actions we just created. Now, I want to add some logic in here. I don't want to just plop. I want to randomly add a bad guy to the game, but I don't want him to be randomly added right on top of where the player is, because that would be unfair, right? We want to add the bad guys to random locations on the screen, but we want to make sure he's at least a fair distance away from the player's current position. Otherwise, you know, the player will lose a hit point, and you know, it would be impossible for him to avoid. So I'm going to add a method called isCollide, and it's going to do a little bit of geometry based on the position of the bad guy and the position of the position of where the player is. So we'll do, actually, let's do this. This dot get position. So we could do, we'll do this twice. We'll do this dot get position, which is the position of this bad guy. And I'm going to add, the second argument is the radius of this guy's position. So we're going to kind of build what's called a hitbox to see if the one side collides with the other side. And on the other side, we're going to check the location of the bad guy in this collection. This is the current bad guy. This is the bad guy we're iterating through in the collection. So those are the other bad guys. We don't want them to collide with each other. And we also don't want them to collide with the player. And we'll do this isCollide method a second time so that the players don't collide. So we'll give him a hitbox of 3. If they collide, get position. I wonder. Well, let's do this. So auto angle, we got to get a random angle. We already created a random function called random for float. Let's get a random for integer. And it'll return int. We'll call it rand_i. And all it's going to do is call rand_f. And it'll automatically cast that to an int because the return value is int. So we'll just call rand_f. And min and max will be passed. And rand_f. Cool. So let's get random integer between 0 and 360 degrees. So auto. And so the bad guy Well, let's try this. I just want to create a move to action. Let's see if we can do some magic with these bad guys to make it look like they're doing stuff on the screen. So create and move to over the course of half a second to get position. And we'll add together, we need to create a vector 2. We're just adding 2 vectors together. Sine. So all the sine is going to give us is the direction of this angle. Like it'll give us a point somewhere on the game screen that's pointed towards this angle. And we'll multiply it by 10 so that he actually moves in that angle. And we'll cosine, so the y needs the cosine. We talked about sine and cosine yesterday. And we'll give some movement as well. So run action. Let me just see if, looks like we've got the baddie. Angle is equal to, and then we'll make him move in the exact opposite direction with the second action. So we're just going to give him some jittery movement. And this will be the run action for the current guy. So actually what this is all going to do, we'll see it in action, but this is just going to, if we make our bad guy appear on the screen, we're going to check to see if he magically appears in a random location on top of another bad guy. If so, we're going to push the one bad guy in one direction and this bad guy in the opposite direction. So it looks like they kind of like, you know, if you ever play pool, kind of how the balls hit each other, they go in the opposite direction. It'll kind of look a bit like that. So move 2, and we'll make him move slightly in the very quickly in half a second. We will do we need to add I think it was CP add. I think this might be deprecated, but we'll use it for now. It's just a method to add points together. So get position, and I should prefix it with this so we know it's the this instance. It's this bad guy. And the second is going to be a vec2, and we do the exact same stuff up here. And I think we close this. We need one more. Cool. And that's it. I think that's it. We need to add this isCollide method, and we can just add it. I'll just be lazy. We'll add it to the header as an inline, because we may be using this in other places. So it returns whether a collision occurs. We take the point of one bad guy, we'll just call it 0.1, and his radius. And then we need to get the point of the second bad guy and his radius. And const float, so we'll do a little bit of geometry here. We'll just get the area of the two, so float A is equal to R1 plus R2. So that's our true full-blown hitbox radius between the two. Const float, and we need a delta x and a delta y, which is the difference in the x location of both and the difference of the y location we'll do next. Oop, difference. So P2 minus x, and so P1.y minus P2.y. So now let's just do a little bit of Pythagoras, and we'll just do this. We'll get the radius. Just so this is our kind of like our big fat hitbox. Our radius is added together, times them, to get kind of a true circle. And if that's greater than the difference in, it's almost like the hypotenuse, right? It's like, you know, if you ever find the length of, you know, a right angle triangle, you'll take the delta of the x's and the delta of the y, and we will check to see. This will give us a true length of their distance. Multiply it by dy, right? It would be basically the delta y squared plus the delta x squared, and hopefully that is greater than the true area of these two radiuses. If it is, then they're not touching. So that should give us what we want. So let's go back to this. Yeah, I think we're okay. I think the bad guy is somewhat working. Let's jump into our game layer, and from here we'll see, you know, what do we want to do. So we should add let's do this. So let's go ahead and game layer. We'll open up the header file. We'll add a little bit to this. So I'm going to add a method called, we'll just call it void update baddies, and it takes a float. Just like player move takes a float, this will be our difference in time between frames, between our game frames. So let's open up game layer. Actually, I'm going to go back here. I'll let this create definition. And we'll go back here and we will find this. We'll make sure we name our float being passed in so it has a variable name, a name to reference. And I'm going to add a private variable in a second inside the header called game time. And we'll do a compound plus equals operation so that game time will just grow in size based on the delta time. So remember, the delta time holds how many seconds between frames that occurred. So it's typically a small fraction. But if it was a whole number, like once delta time equals a total of 1 second or 1.0 as a float value, then that's 1 second that's elapsed. So I want to capture each one of these delta times to see how many seconds have elapsed in our game. The reason why we do this is because I'm going to slowly add bad guys every, let's say 5 seconds. So if this, before I do it, let's go ahead and create this float and initialize him to 0. And we'll make it a private variable because we won't be accessing it outside of this class. So game time will be 0 seconds. And then we're continuously adding a slight fraction of our time as time elapses during the game. So if game time is less than, let's add we need to know how many baddies are on the game later. So I'll add an integer called baddie count, and we'll multiply that by 5. So what's going to happen is baddie count is going to be how many bad guys are on the screen. So let's say there's 5 bad guys on the screen. So 5 times 5 will be 25. And our game time is the time growing as the game progresses. So after 25 seconds of gameplay, then we'll add another bad guy on, because game time will be greater than the bad guy count times 5. So all this logic is really saying is every 5 seconds of gameplay, we're going to add a new bad guy. Or I should say every 5 seconds of gameplay, we're going to go in this if statement. I'm going to increment baddie count by 1. So that's saying, oh, there's another bad guy added to the game. And then we need to have a method called add baddie. Sounds like a good enough method. But first I'll define this in the header as a private integer. So baddie count is equal to 0 because we start out with 0 bad guys. And that'll just grow over time. Let's go ahead and add a method inside of game layer called add baddie. And that'll just do the logic to instantiate a new bad guy class and plop them randomly on the screen. So let's go back to the header and let's go ahead and add a method void add baddie. Wait for the squiggly. Okay, so we've got our baddie, add baddie. So now let's go ahead and implement that method. Probably got added near the bottom. Where the heck is it? Here we go. Okay, cool. So let's go ahead and add a bad guy. Add a bad guy. So here's what I'll do. I'm going to create a vector called pool. And the reason I'm doing this, we're going to pool our instances of bad guys. So when we add a bad guy, we're going to push it into this vector so that it's always there. This is kind of a common pattern in game programming where you pool things instead of instantiating them in memory every time you need a new one. So what you do is you create a bunch of bad guys, you stick them in this vector or this container, and you just pull them off of the container as you need to add them to the game screen. If you didn't use a pool, over time, instantiating and putting new, for example, bad guys in memory, it would just strangle the available memory on that running system. So we'll use the concept of a pool. So I need to create a vector that contains sprites and pointers to that sprite, and we'll call it pool. I need to reference our vector source code, and that's in the std namespace. So let's just see here. So we should probably initialize that vector and give it a bit of size. So what I'll do here is, you know what I might do? Cocos2d-x has their own vector. They just simply wrap the standard namespace vector. I suppose I should play nice with what Cocos2d-x supplies us. So we're going to put him on the stack, on the memory stack, and reserve 100 spots. Sprint. So sprite. So now we've got our pool that can store 100 sprite instances. If we go beyond 100 sprites, that's fine. It'll just resize this vector, which isn't exactly fine, but it is what it is. Let's go ahead and got that defined. We can go ahead and go back and start working with this. So what do we want to do with this? We want to, if it's empty, we'll push a new instance of a bad guy onto the pool. So we'll new up a bad guy. Sweet. Okay, so now I'm not going to do a whole lot with the pool yet. I may not even optimize too much yet, but let's pop off that pool. That bad guy we just pushed on. It may look like, well, why are you using this pool, pushing and popping? We'll optimize it a little bit later, but let's just pop off what we just pushed onto that pool. So if we go pool, there's a method called back, which simply takes the last element on that vector container. So the last element we know is going to be this guy we just pushed on. And I need to cast, because the pool is storing sprites, but what we pushed on was a bad guy. Even though bad guy is a superclass of the sprite class, because we inherited the sprite class, we still need to cast it or upcast it. And we know it's a pointer to baddie, so that should fix it. Okay, so I'm going to pop off the pool. I'm going to remove that guy that we just pushed. We just captured an instance of. So right now this pool isn't really working as I want yet, but we'll make it work in a bit. So baddie. Now bad guy, when we construct the bad guy, the init method works and gets called. But I'm going to add a new method on him called prepare. And that's going to kind of initialize some of the bad guy stuff. So I'll do a prepare to kind of set his color, like random color we need to set on the bad guy because he'll have a random color associated in the game. Remember the mechanics again. If the bad guy is the same color as the player, then the bad guy can't attack that player. But if he's a different color, he can go ahead and attack that player. So let's go ahead and we'll add, oh, we got our method prepare. So where is our prepare? Prepare. So let's add some logic inside of prepare. Okay. So let's define a string. So I'm going to include, what I'm going to do here is I am going to pull off the animation for the color of the bad guy. So you'll see what I mean in a second. So std string, and we'll just call it image, and we'll initialize that to an empty string. So I need to use a Cocos2d class called sprite frame, and it's a pointer too. So sprite frame is going to be one single frame in our sprite sheet to represent our cell color. So we're going to use these cells here. You can see the green one up here, the red one here, and the blue one here. And those guys have a certain name. And I know what they are because the name is defined in the P list for the sprites. Remember, we used that P list previous day. So I'll just call out based on the color that this bad guy is going to become. So we need to randomly get his color. So let's go ahead and use that rand_i function I added. And we need to put a minimum and we need to put a maximum. So this is going to give us a random number between the minimum of 1 and a maximum of 3. So yeah, so RND after this line is going to be either 1, 2, or 3. And those will be one of our 3 colors. So all we have to do is say if RND is equal to 1, we will set the sprite that we want to red_1.png. All right, all that's doing is it's going into the sprite sheet and it's finding an image with that name. This is blue_1, but there's also a red_1 in here. And we will say his color. We need to store the bad guy's color as color.red. Because without this, we won't be able to have the logic to say if he's red and the player is blue, then this guy needs to attack him. So we'll else if, and it just repeats. So if it's 2, he can become, let's say, green, and if he's 3, he can become blue. So we'll say green, and we'll set his color to green. And then since we know the only other option is blue, we'll just add an else statement. We don't care that random is actually 3 because there's nowhere else to go. I'll copy this again. So blue, and we'll set his color to blue. Perfect. Now we need to work with that. So let's actually pull from the sprite frame cache in Cocos. So we've defined that frame variable up here. We need to actually get the sprites out. So we're going to go to the sprite cache. Remember, the sprite cache got created inside of our core init right here, where we, stored inside of our sprite cache all of the sprites from that sprite sheet. So all of these guys are individual little sprites now, and we can pull them out based on those key values, right? The names inside of the key property. So let's go back to Batty, and we'll get the sprite frame cache. Again, it's a singleton, so pretty much you're going to see get instance calls everywhere. And we can go sprite frame by name, and we have that name. It's stored inside of the image variable. So based on this string, we're going to actually get the sprite back out of the sprite sheet. So now he's got an image. Now let's set, we want to actually set his display frame to this frame. So when we initialized him, he was initialized with the frame blue_1, which is great because it gave us the dimensions of what a cell is, of what the sprite's going to be. But we have to override that sprite with the one that this random function gave us. Okay. And we should actually set the radius. So we need this radius. I'm going to add, we're going to add a function, and we'll call it just calc radius that takes in the this object, and we'll simply add that in the header. So what we need to do is calculate a radius based on the size of this sprite. Okay, and we want to store it as a radius. I know it's stored in Cocos2d-x once we initialized it, but I want to store it as my own variable and have my own radius for this sprite. I don't want to use the Cocos2d-x. I want to kind of do that because I want to control the hitbox. What I mean by hitbox, again, it's the radius used to check for collision when the player gets near that sprite to see if they actually touched. So calc radius, and remember we passed in this, and this, it could be a baddie or it could be something down the inheritance chain. Remember, he inherits from the sprite class in Cocos2d-x. So we're going to say sprite, and it's an instance or a pointer to sprite. So we'll just say S is good enough. So return, pretty simple. So we're going to use some of the Cocos2d-x stuff to help us. So we'll say get scale, and scale by default is 1.0. That's the scale you scaled your sprite image. We'll just say get scale. It'll be 1.0f unless we change the scale. And we might do, like, once we make the game kind of roguelike based on, you know, once you complete level 1, it's going to get harder. So we can scale maybe the size of these bad guys to make them bigger. We'll see. Anyway, so we get his scale, which is going to be 1.0 pretty much all the time. That's just the default scale. So content size. So we're actually getting the sprite size. And because the sprite is a circle, all we need is width. We don't need height. And I'm going to multiply that by 0.5. So all this is saying is his radius is going to be the scale, which is 1.0. So that's kind of moot. This can almost be just removed. The sprite size, well, it's going to be approximately, let's say, I don't know, what does that look like? Maybe 100 pixels wide. So we'll say 100. And then we multiply it by 0.5, which is really just a division of 2. So it's going to reduce his radius to be smaller than the actual sprite itself. That way the player, when his little tentacles here hit the cell, it won't trigger a collision. Actually, the nucleus of the player's cell would have to pretty much touch because the radius of the cell will be a lot smaller than the cell itself. If that makes sense. That will do the job for us. So we've got this radius, And we're not going to use it now, obviously, but we're going to use it when we start doing some collision detection. So finally, when we initialized this bad guy, we set him to invisible. So we want to make him now visible on the screen. So this set visible, and we'll pass in true. And that should be it. We get a color for the bad guy. We set his image to be that color cell. We do that here. We give him a radius for our collision detection, and we make him visible on the game screen when he's added. Okay, we're getting closer. Let's go back to game layer. So our prepare method is done. So we're adding a bad guy. So all of that stuff we just did is going to be adding him to the game layer. Now we need to set his position randomly on the game screen. So let's do that logic now. So position, we need to know the dimension of our game. So we use our director, and it will tell us the size of the running game window. So perfect. So now we've got the window size, so we can make sure he randomly appears somewhere in the bounds of the game window. So I'm going to do this in an infinite loop, and I'll show you why in a second. So we've got an infinite loop, and it's a do while loop, which means you always do one iteration until you check the condition down here. So let's go ahead, and we need to do some collision detection. So fortunately, we added that isCollide method here. So we're going to do a little bit of a check. We're going to randomly create a position for the bad guy to appear. And we know his radius, so we've got that. And then we want to check it against the player's position, which we'll pass in here. And we want to see if they collide. The reason is, we talked about this before, we don't want the bad guy to magically appear on top of where the player is. So we do this infinite loop, and if they don't collide, we break out of the loop, and that's where we put the bad guy on the game screen. If they do collide, then we loop again and create another random location, and we keep doing that until they don't collide. That way we're assured when we push a new bad guy into the game, he doesn't just magically and unfairly appear and damage the player. So let's do a little more geometry here. We're kind of cutting back on the geometry. We're getting near the end of any sort of math, but we first need to get a random x coordinate between 0, which is our bottom left hand, sorry, since it's x, it's the far left hand of the game window, to the full width of the game window. Just to make sure we only plop him within bounds. We also need to get a random y location within the bounds, and 0 to window height. Cool. And let's use our position and create a position based on that random x and the random y. And now all we have to do is a conditional check to see if they've collided. So if isCollide, and our isCollide needs to have, we'll pass in the position of the bad guy. So we can just say POS, which is our position, which is our x and y coordinate. And remember, we just created the radius of the bad guy, so we can go baddie and get radius. So now we know his location and his size, and we'll compare it against the player's position and the player's size to see if there was a collision. So player, we've already created player a previous day, so we want to get his position, and we want to get the player's radius. Get radius, player.getRadius. Maybe we didn't add this. I thought we did this the other day. Okay, so let's go to player and make sure we calculate his radius. So let's open up the player.h, and let's define a constant for the player radius. So const float k player radius. I think a good radius to use will be 10. That's probably a fair size. So const float player radius 10, and then we have to add a getter. So we'll add a getter to wrap that, and we'll just say get radius, and I'm waiting for the squiggly, and all I'm going to do for now is just return that constant. So k player radius. We'll save all that. We'll jump back to here, and now player radius should appear, and it'll give us 10, which should be good enough for now. So if they don't collide, so I'm going to put a not here, that exclamation. So if they don't collide, then we're going to break this loop. Okay, so if they don't collide, then we can set this point as the point we want to randomly drop the bad guy onto. So we can simply break out of this infinite loop by adding a break statement. We've already stored that random position that did not collide. So we need to do a little bit of logic outside of this loop. And it'll be set the baddie to set his position to POS. Cool. So we know he doesn't collide. You know what I'm going to also do? I'm going to actually make the player's radius 3 times the size of its radius. So what I'm saying is make the player really fat and big, just so that this random position that the bad guy is going to be dropped will still be very far outside of the player radius. So we'll just make the player a little fatter to make this hitbox a lot bigger. And therefore, if the random position is close to the player, then there's still going to be a collision, and it's still not good. Because if we drop the bad guy, even though they don't collide, but the bad guy is like a couple pixels away from the player, then you won't have enough time to respond to him attacking you. So now that we've got the position, if you remember Cocos2d-x, everything was a child. So you've got these parent-child relationships. So this is a scene. In that scene, you've got a game layer, a layer, and inside that layer, you've got sprites. Anyway, for those sprites to appear, you have to add them as children to its parent. So in our case, the game layer, you'd have to add the sprite as a child to it. Yeah, so let's just go back one. Add child. Let's just see. Let's just see. Here we go. So without, what we're doing in Cocos2d-x is we created a scene, right? Our game scene. We put our game layer onto that scene, which is the child of the scene. Then we put all of our sprites as children under that game layer. If we don't add them as children, then when we pass that scene into Cocos2d-x to run, to play our game, then if we don't add those children to that scene, then Cocos2d-x doesn't know to render them. Okay? So we have to make sure that we call add child to basically any Cocos2d-x object we want to display in the game. So we can do that by making sure if not baddie has parent, so we can just say get parent and check for null. So if this returns back null, then this not will say go into the if statement. So if he doesn't have a parent, we need to add him to the game layer. So this add child, and we'll push the baddie, which derives from the sprite object, onto add child. So the reason why I'm doing this in an if the baddie doesn't have a parent yet, do this. It's because once we start using the object pooling, we're just going to push bad guys back into this pool vector, and they may have already been added to the game layer, so they do have a parent. It's just we probably made them invisible. But we'll get to that. I don't want to add too much logic difficulty right away. Okay, so we're going to add him. We can give him a Z order. So let's say, I think our highest order is 1000, and that was our overlay, which is our blood splatter as we get damaged. So we'll add the bad guy just below that. And we'll give him a name. That's just a reference name. If we ever want to use a tag or a reference name to get children off of the layer, off of the parent, we may not even use this, but I'll just throw that in there for now. Okay, so what do we got going on? So forget the pool stuff. We instantiated a bad guy, and that called the init method. So in the bad guy, when we instantiate, we call the init method. In the init method, we just initialize it with a single sprite just to give it some dimension, and we make him invisible. And that's fine. Okay, so he's invisible. But then we call prepare. Prepare is going to randomly get his color. So for example, he might be green. So we set him to be the green sprite, and we set his color to be green. And then we make him visible. We give him a radius. Sounds great. Then we randomly plop him somewhere in the game screen, as long as it doesn't collide with where the player currently is at. We do that. If he isn't added to the layer as a child, then we do that. Otherwise, he won't be rendered by Cocos2d-x. And now let's work with some of the artificial intelligence stuff. So let's go ahead and we'll get his color, which was randomly generated when we did that prepare. So baddie, get color. Okay, so if his color isn't equal to the player's color, so if he's not equal to the player color, then they're enemies. The bad guy is going to go on the offensive. So we created those actions, finite time action. So we want that move action. We want to get that move action we created earlier. So we can go to the method that the function we created called get move action, I think. Perfect. And that'll return that move action we created. Now, if the move action is valid, we'll just check to make sure it didn't return null. If the move action did come back, then we actually want to run the action on the bad guy. So let's go ahead and run that action. So previously we just created the action. Didn't mean it was actually applied to anything. We just had it prepared. Now we're actually going to run it on this sprite, on the bad guy sprite. So he's now going to move. Let's also do that repeat action where he scales up and scales down to make it look like he's throbbing. So action interval, action is equal to baddie, and we called it get repeat action because it did repeats. And it's just him throbbing bigger and smaller. If that action came back as not null, then we'll run it. Run action. Cool. So now if the player and the baddie are different colors, the bad guy is going to move to the player. And when we add the bad guy to the game, he will always repeat this action, which is his scaling up and like shrinking and growing, and it repeats forever. Perfect. So we've got that. Let's just try. I'm going to actually compile this. Control-Shift-B. See how close we're getting. All right, compilation, everything's successful, cool. So we need to do a little more work here. Very little work, but we're almost there. So we've done our add baddie function. Now what we want to do is we've got our updates. Every 5 seconds a new bad guy is going to be pushed into the game. We need to call this update baddies in our update function. This update function, if we go to gamelayer.h and find the update function, notice the virtual keyword in front of it. It means we're overriding the update function that belongs to our base class, which is the Cocos2d layer. So by us overriding this, it gets called by Cocos2d-x for us every frame. So this update will get called every frame by Cocos2d-x. We're not calling it, Cocos2d-x does. And we will simply call update baddies and pass in the delta time. So the logic we created earlier, we just start aggregating the change in time together to see how much time has elapsed in total. And we can add our bad guys. So let's give it a shot. Cool. So awesome. One bad guy. You can see him, the infinite scaling action, shrink and reverse, grow and reverse. And then this is a different color, but he's moving away. This guy's moving towards me. Let's just play here. So he shouldn't move at us because he's the same color. Let me move the logic. Where's our game? Where is my game? Okay. So our game is running. Let's move our player. Okay, so now we're blue. The red is going to move towards us. Blue, it shouldn't move towards us. Who's going to get added next? 5 seconds of red, and he's going to move towards us. The red moves towards us. And you can see they're also growing and shrinking. Perfect. So now we need to do some of the collision detection stuff and actually do some hit points. So let's go ahead and do that. So we know that the bad guys are getting added successfully. So let's go ahead and update bad guys. Here's what we'll do. We'll add another method that gets called within this update method that gets called every frame by Cocos2d-x. And we'll just say handle collision, and we can pass in delta time. Handle collision, we will create that method, void handle collision, and takes in float. I don't know if I'm going to do anything with float. Make sure we implement that. New method, handle collision, float, DT is just as good as any name. Okay, so now what do we want to do? So we want to, maybe we will use that pool. So maybe I won't pop, add bad guy, pop him off, pop off back, pop back, get back, pop back. And, you know, this is a bit hacky, but it'll do for now. Get back, pop back. Let me just think here. Maybe I won't even pop these guys off because we're pushing add baddie. If it's empty, we put a new guy on. That's great. Pop back, baddie prepare. If empty, new baddie. Let me just do this. Always push a new instance of a baddie on. We pop the guy, we get the back baddie on the vector. That's fine. And do I want to pop him off? I don't think so. So I want to use this pool to actually hold all the bad guys that are currently in the game layer. I think we're good. Okay, add baddie. So handle collision. So we want to loop through the pool, the vector that contains all the bad guys we've added to the game layer. And we want to check to see if they have collided with the player. And if so, we're going to have to deduct some hit points off the player. Okay, so let's do something like that. So delta time. So let's go ahead. If pool dot empty, if there's no bad guys, if the pool is empty, we can just return. There's no point doing any logic. So let's go ahead now and player move. We're not using player move. I'll collapse it. Let's go ahead and okay. Anyway, so let's go ahead and we should probably loop around and find all the baddies. So let's go ahead. Let's go ahead and we'll do this. So const auto. No, I don't need that. Let's do it. I'll just do our for loop and get the iterator. Just like we did earlier. We'll get the iterator from the pool and get the begin of the iterator. Remember how iterators work. We get the first location of an element inside of the vector that contains multiple sprites, multiple bad guys. And then we check to see if we're not at the end of the iterator, then we keep iterating. So end. And then in this portion of the for loop, we increment the iterator by 1. So we move element by element. And it's not I, it's IT. Okay, so now we want to make sure we get out the bad guy. So baddie. So we'll just call it baddie is equal to dereference the pointer. And we'll probably get a red squiggly here because we need to cast the type to baddie. So we'll upcast because remember the pool contains sprite pointers. Baddie derives from sprite, so we just simply need to upcast it to the Baddie superclass. So let's do some logic. So we want to do that is collide against the player. Okay. So if is collide, and we need our point 1, right? Let's just do on the left-hand side, we'll check the Baddie's position. We'll push the get position of the Baddie. And he's got a radius, so Baddie.get radius. So our little hitbox check. And then we need the player, underscore player. We'll get his position and his radius, which is 10. And we may adjust that. Player dot get radius. So if they collide, then what do? Well, we can maybe destroy the Baddie, because like I guess he expends his attack. So what should we do? We'll destroy the Baddie. Then we will deduct 1 hit point from player. And that is it. I think that should do it. So we'll destroy the Baddie first. So we've got the Baddie. We first need to pop him off the pool. Let's take him out of the pool. And to be honest, the name pool is kind of the wrong name now, because it's not really a pool manager to hold instances of bad guys. It's actually just a vector of all the active bad guys. Anyway, this will work. This will work. So if the vector of bad guys contains Baddie, it'll actually do a reference check, like a does this instance of Baddie, is he in pool? Well, he should be, because we pulled him from pool, but we should do this. Now we're going to have to update our iterator though. I have to remember how to do that, because our iterator, if we remove a Baddie out of the pool, which is what we're iterating on, then this iterator is going to be out of sync if we pull something off of the iterator, right? Because remember, the iterator is just like a little kind of a pointer to that element. Now, if we pop one of the elements off, then we kind of screw up that iterator. It needs to get refreshed. So if contains pool dot remove let me just see the methods we have available. Returns the position of the element. We could do that. I'm just trying to remember if I mean, I guess I could go to onto Stack Overflow, but let's just give it a shot here. Replace, reserve, swap. Well, let's get at not at. How do I remove that object? We know he exists. How the best way to erase? Let me see. Erase removes a certain object from the vector. So maybe it's erase. I can erase by the index. Erase object is probably better, since we have an instance of the object. Okay, let's try erase object, and we'll pass Baddie in. So we're assuming that's going to simply erase, And remove all, I guess, if that same instance is in multiple locations in the vector. But we'll just default that to false because each one of these are unique in the vector, each bad guy. So we got to destroy it. Now we need to update iterator. So it dot, how do I update? How do I update? I need to just remember how to update. Update, 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 update. Let's jump to, let's see, update iterator in C++. Update vector iterator in C++. How to update vector elements through the iterator. Update vector elements through iterator. We'll have a look here. IT gives you a reference to the element, and that reference can then be assigned to iterators. Behave similarly to pointers. Keep that in mind. Update begin. Let's go remove elements vector iter. Let's just see what that gives us. Remove as I go. This sounds like kind of what we need. So remove if. So it looks like we're going to have to include the algorithm source code, and there's a free function called remove if. Now assuming I am here, this guy seems to have more upvotes, so I kind of like this. So vector of strings, he created an iterator of a vector of strings. Sounds good. He did the same thing we're doing, begin, end. He's incrementing his iterator and his inside of the loop, and that's fine. Iterator, I get it. Erase. What is delete file? So he deletes that guy, and from mv paths, which is our vector, he called erase on that, passing the iterator. Okay, I think we're okay here. So let's go back to Visual Studio. So we want to update the iterator. So we go underscore pool dot erase. I am doing it wrong. So erase iterator, it, and get our it back. So we don't need to destroy the baddie in that line, because all we're doing is the iterator's already pointing to that element. So we erase it and we get a fresh iterator back before we continue our looping. So I think we are good to go here. Okay, cool. And then we need to deduct 1 hit point from the player. Okay, so we aren't storing hit points yet. So let's start adding that logic, and I'll actually just put it in core. We'll create a private variable, I don't know, unsigned. Could be unsigned short because it'll be a low amount. Player hit points, and we will give him 10 hits. And then we're going to wrap that in a getter. So unsigned short, get hit points. And let's go ahead and I'll just add a method called player hit. So let's go ahead and implement these methods. So get hit points, we simply return back player hit points. Player hit, we're going to remove from player hit points. So we can just use our postfix decrement operator. It's no different than player hit points -1. So either or, I don't really care. And then we'll have to do a check during some of our looping on the frames to see if the player has 0 or less hit points. So he's taken too many collisions and game over. So we've got that. So let's go back to our game layer. So now we deduct a hit point. So core. Our game layer core. So we're not storing core. That's fine. I'll just I'll go that. And now we have a pointer to our core instance where we just added the player hit. So player hit's going to decrement his hit points by 1. Cool. And I could do our check to see if the player is dead at this point. Let's just see. So we erase that baddie. You know what I need to do though? That baddie. What are the methods we added to baddie? Because we need to pop this guy off the game layer. So we want to destroy him. I guess I could just set him to null. I could delete him, which would call the constructor and turf all the actions. Let's go back here. We could just say, so let's just go this dot remove child. So we're going to remove that baddie from the game layer as well. We need to do that before we erase him out of the iterator. So he'll no longer display. And remove child. And then I could delete him from memory. So I could go delete on him because we newed him up. But I'm thinking I want that explosion to occur because we actually loaded up a explosion animation suite. So we can go ahead and trigger the animation using the constant tag named explosion. So animation cache. Let's just try that. So get instance, and we want to get an animation by the name, and the name was, that, like I said, on other days, this should be a constant somewhere instead of us hard coding a string that actually cannot be, it's not arbitrary. This has to be spelt exactly correct for it to go into the animation cache and find the animation named explosion. So what does this return back? It returns back a Cocos2d animation instance. So I'm going to make this bigger so we can see everything. Explosion. Let's just see what we have available to us. So we don't need to add any sprites to this animation. That was already done for us. Create with sprite. No, that should be fine. Get frames, get loops. Init with animation frames. Release retain. Set delay. What is the best way to display the explosion animation? Because I need to set this animation in the location of where this collision occurred, where the bad guy currently is. Init, release, retain, set frames. Let's just have a look at the documentation. So let's go ahead and how do I? There was little arrows here somewhere. There we go. So let's go until we find animations. Hey, just looking at the chat. Sorry, I wasn't following. So who's this? Oni LOL. Hey man, I'm relatively new to programming and I'm just looking for tips on the most efficient way to possibly learn and really understand, take in things. Thanks a lot for streaming your help. Yeah, I get it. You're new to programming. It's tricky, dude. Like, go look at my previous videos that are archived. And I still am doing a C++ intro, which is completely from zero starting point. We cover like everything: data types, if statements, like conditional statements, looping statements, everything you need to know about C++. The course, though, I've only been streaming on Twitch for probably a few weeks, I guess. I don't know when I started. And I don't have the course completely done yet. So that course starts from kind of zero and it takes you maybe a third of the way there. So you can start with looking at those videos. I think that would help you a lot because we're building a game right now. And unfortunately, it's expecting you to know some basics of programming and definitely of C++ because we're coding in C++. So it's going to take a bit of time. And I know I'm kind of going fast, like creating this game. If I went any slower, it would take a long time to build. And I kind of want to wrap it up by tomorrow, this game. So yeah, and then I'm going to start streaming the training courses again. So make sure you follow, and I'm going to actually update my homepage on Twitch to include what I'm covering for the week. So like you can come to my homepage and it's like, oh, I don't really care to see him do a Cocos2d-x game. So I'll sit that one out. But I see on, let's say like Thursday, he's doing, C++, basic training. I wouldn't mind doing that. So, just follow, and I'm going to definitely update my schedule a lot more descriptive than it is now. So you know exactly what I'm going to do. Okay, let's see here. So what am I looking for? What the heck was I looking for? We are the explosion. So we're looking for animations. I just want to get that animation. Anyway, animation. Sequences, we did those. They were just sequences of actions. Building and transitioning scenes. UI components. So we're going to do UI components too. On our running game, we're definitely going to want to put labels like, our score and how many hit points we have left. So we're going to be adding labels, buttons. So I'm going to fly through this because if you were on previous days listening to the Cocos2d-x training, you would have heard me complaining about their documentation. There's no table of contents. You just have to skip through and hopefully you'll hit. Here we go. Animation. Hopefully it's not just 3D animation. It is, but create animation, run with action. So the animation is going to be like an action. So cool. So we can just run it on the dude. Cool. Okay. I think that makes sense. So I'm wondering though, before we remove the bad guy, let's turf this. Let us turf this. And I'm going to cut this so I've got it on the clipboard. And let's go ahead and add a method to Batty. And we'll call it remove Batty. so since that doesn't exist, let's go back to baddie and we'll define void remove baddie. I think that's what we gave the name. Remove baddie sounds good. We'll let Visual Studio add the implementation in the class file. Let's save that, jump to the class file, remove baddie, and we're going to add some of that logic in there. So this remove child has to be done in the game layer. Unless I pass the game layer in as a reference. Maybe I will do that. Maybe I will pass in node reference game layer, and we can do this. So instead of this, it'll be game layer remove child, and we'll use this because we're inside of the bad guy instance. We're inside the bad guy class, so this would work. But we're going to remove him after the fact. Okay. Let's just quickly jump back to here, and it expects us to pass this in, which is the game layer. Too many arguments. Game layer. Oh, I didn't update the header file. No big deal. Oh, I did. No, I didn't. Sorry. Okay. Node star. We don't need to define the type. Let's save that. Squiggly goes away on here. Cool. And the squiggly should go away now on here. Good. Okay, so now let's add the explosion as a running action to our bad guy. Okay, so we get the explosion from the animation cache, and we created the explosion when we initialized our core class in a previous day. So let's go ahead and I'll move this over, and we will simply run with action. I'm just going to copy this. And we'll add this here. Yeah, I'm just looking at the chat now. I'll take a pause. So nice, dabbled around HTML, CSS, JavaScript. If you're a JavaScript guy, you know what I would use? Like if you're interested in game programming and you're more comfortable in JavaScript, you can definitely watch these Cocos2d-x videos. But you can go to cocos2dx.org and go to products and yada yada yada. Oh, it's okay. I'll show you where to go here in a sec. I want to go to GitHub. Let's go to GitHub. And we'll go to their root GitHub page. If you're into JavaScript, you can use Cocos2d-x, but the HTML5 version. I think it's actually called Cocos2d-js now. Interesting. Maybe they didn't rename. Here we go. Cocos2d-x for JavaScript. Let's just do this. Let's go here and let's see. Here we go. Let's click on the website. You can learn, you can watch this game and see how it's kind of progressing. And everything that's in here is in C++, but if you want to use, yes, definitely translate. Cocos.com. Where the heck are you? You know what? Why am I doing this? Cocos2d-js, I know is the project. So there's a YouTube video on how to use Cocos2d-js, and there's the source code in here for it. And there's lots of samples. You can download it. You can use the online demos. You can use the getting started pages. I recommend, if you're more comfortable in JavaScript, download Cocos2d-x. Start by going to their GitHub page and do the get started documentation. I built one game with Cocos2d-x. It's identical. It's got the concept of frames and animations and actions. So, you know, if you feel more comfortable in JavaScript versus C++, then feel free to go there. Okay, so back to this. So remove baddie. Before we do that, we want to push this animation onto him. This first, though, this dot, it's not really dot, it's the dereference pointer, but we want to stop all actions. So we want to stop all his actions. Then we want to run the action. Not repeat forever, but repeat. Maybe just repeat, create, and how many times? So let's just pass explosion. And we want to just repeat that action once. So it seems like explosion, we should wrap it probably in a sequence. Let me just look at that help file again. Where was I? So repeat, animate, animation 3D create, animation 3D create, repeat forever, create. Sprite run action. Well, let's have a look. Animation. What is the trouble? So it expects a finite time action. Fair enough. So we'll work through this. Finite time action. Can we create? This is a base class of actions, so we want to create I want to create, do I just want to create a sequence? We can try that, see if the action will go inside of here. Expects a finite time action, so that isn't going to help me. How do let's just look at the different actions that pop up. Action. Let me go back to the help. I'm going to actually get out of the 3D stuff. Maybe I bypass the animations. Since we know we need to push it into an action, it's not a move by. Sprites. Well, you know what I can do? Let's go here. So we have an animation running on our player. And I clearly have a brain fart going on how I pushed it onto the player. So let's look at our player and probably the init. So we created the animation create from the animation class. Okay, the animate. And then a repeat. Okay. Okay, I think this will do the trick. I want to new tab just so we've got this open while I muck around a bit. Stop all action. So animation cache, we get our animation back. I think that's deprecated. That's fine. So animate, create. So animate, animate, create, and we'll pass in our explosion animation. And then we shall, let's just see if that will. So that derives from finite time action by the looks of it. Action interval and perfect. So that's what we were missing. So we'll stop all the actions on the bad guy, like his throbbing and his movement. And then we'll replace and run the action of animate, which is the explosion. And we do it once. Sweet. Main sequence. Yeah, I think that's okay. And so game layer, remove child, this. What we should do though is after the action is done, we should do a callback where we destroy everything. So let's do what we did here. Create a sequence. And I'm going to F12 into this sequence. So he's action interval. Perfect. Okay. So what we'll do is we'll create a sequence. And I'll just do auto, because I'm not sure the return value yet. Sequence, create. And so we want a finite time action, and we know animate is. And we want to pass in a callback to a method function. So I'll do that on a second line. So this CC callback selector, clearly I have a typo. Cool. So change color. So we need a baddie. Destroy me. Sounds good. And that closes, that closes. Yeah, I get it. Okay, so let's go ahead and add destroy me. I mean, I guess I could just put it as private. So void so cool. So now destroy me. What is the issue? Am I unlined up? I might have an extra. Sweet. So, okay. So the reason why we added the sequence is because we can animate, and then once that animation finishes, we can do a callback to another function where we actually destroy this guy. Okay. So let me just see. I wonder if I can pass call func selector. I hate passing things. Yeah. Well, let's figure this out. So run action, create, animate. Let's just run the sequence. Run action, repeat once. I don't know if I need this repeat. I'll comment out this line, and I'll just pass in the sequence. So we'll just run that in the callback, and where is destroy me? I added you, but I did not create you. Okay. Okay, so where did I put destroy me? Way up here. So now what do we want to do? We want to, what's the best way to destroy him? So this I might actually take this out of the destructor. So we definitely want to do this. We want to remove all actions from him. And we could probably add some more. Let's just leave it at that for now. Let's just try this. Okay. So game layer, remove baddie. We're not using this yet, but that's fine. The animation will occur. Buddy gets pulled out of the iterator and deduct 1 hit point from the player. And then obviously at some point, we could do it in here. Test if game over condition. It's probably not the best place to put that. It'd probably be in another function, but for now, this is good. But before we do that, let's just see how close we are to running this. I might actually put a breakpoint for each. I just want to see how we're doing here with this. Come on, let's load up. Sweet, play. And handle collision, of course, gets jumped into right away. Pool has 1. And we have a baddie inside of the pool. Awesome. Okay, so you know what, guys? I'm just going to take a 5-minute break, okay? I just got my dog wants to go outside, so bear with me. I'm just going to put the break screen on, and then we'll get back to it. So. Okay, I am back. So where did we leave off? We were going to test out some collision detection, some hit detection between the bad guy and the player. We got to get that animation going, and we got to check the game condition, the game over condition. Cool. So I just want to debug through a little bit of this just to see how we're doing. So we get our one bad guy. We'll do our collision. I'll just drop the breakpoint in here because we'll see when we hit that. Try to make a collision occur. So I could do a collision here. We may actually have a bit of a bug because these guys are the same color. So I would actually have to add a bit of logic in here to say if they're the same color, then we actually gain points. Because, right, the game mechanic is you want to eat the cells that are of the same color as you. If so, you gain points. Once you gain a certain amount of points, you can level up, right? You progress to the next level. Anyway, so we did hit a bad guy. Unfortunately, he's of the same color, but it'll allow us to test our stuff here. So if pool contains, so it does contain that bad guy. Now we want to remove him. And then we want to update our iterator and keep looping to see if other collisions occurred. So let's step into that. And we'll use game layer a little later. I may have to change this callback to allow arguments passed. You'll notice this uppercase. This is a macro. This actually gets replaced with actual real code. So you can see right here, that literally gets replaced inside of or where you saw all that uppercase type. So what the heck am I doing? So that literally gets replaced with code. Okay. Okay. So we got to get the explosion animation. Yeah, we've got a handle to it. You can see the memory address is valid. It's not a null or like zeros for a null pointer. So let's go ahead and create our animation. Our animate is gold. Cool. Let's create our sequence so that we animate. When that animation's done, we call destroy me. I better just drop a point up here. Just make sure everything's kind of going. We just created the sequence. We haven't actually run this yet as an action until we get down to this line. So we're going to stop all actions on that bad guy. So no more shrinking and growing and any movement that may or may not be occurring. So stop all the actions. And then let's run the animation. I might drop the breakpoint on. Well, I'll put the breakpoint on here. Let's see if we can quickly see if the animation appears. Oh, crap. So we're stuck inside of the loop. Okay, well, we can test it hitting another guy to see if the animation appears. So now we want to erase this bad guy out of the iterator, out of the pool, and update our iterator. So now our iterator, we shouldn't loop anymore. Our pool has 5. Oh, so we've already added 5 new bad guys over time. Hopefully the guy we were working with though has been popped off the pool. If not, we'll have to look at that. Then we get core player hit. Step into that. We should deduct 1 off of 10. His player hit points are 10. I hope. I thought I defaulted player hit points to 10. Well, let's see what happens here. So I'll step over. Yeah, 10, and that should be now 9. Perfect. So he took a hit, and he's slowly decreasing in hit points. And then we'll put a label on the game at the top, really small label to say how many hit points the player has, so you know how well you're doing. And then as well, we need to, let's just go back to our resources. So we need to add music in and sound effects as well. I know there's still quite a bit to do. Yeah. Images though, when we take damage, we want that overlay. Overlay. Element O. Okay, here we go. So when we take damage, this is on the game layer right now. This ugly green, you know, splatter, fluorescent green splatter. And this is going to represent, you know, like a cell's blood as he's taking damage. And we're going to change the opacity to become more opaque as he takes damage, right? It's fully transparent right now, so you don't see it over the game layer. But as he's taking more damage, we'll slowly make it more opaque and more pronounced. And it's really high up in the Z order, so it'll show above everything else that's drawn on the game layer. So we'll also add that after we get this hit point stuff taken care of. Cool. Okay, so where are we? I'm debug. So we saw that we're taking damage. Life is good. There's more guys to check for collision. Cool. So we iterated again, and we didn't go into the loop again because there was no collision. And that's good because that's telling us we popped off the bad guy that we just removed. And remember, the destroy me gets called after the animation is done. So the animation actually just occurred and now it's gone. And now the destroy me gets called. Remember the sequence. This gets done first, then this gets called after that is done. And then nothing gets called after that. So destroy me, remove any actions from the bad guy. And then we'll have to call his destructor, delete him from memory. And we'll do that. But we'll just test this for now. So no errors. Oh, the animation is there, but it didn't get removed. You can see the smoke is still there. So I have to look at what's going on. Now I want to run into some, I first want to take off the breakpoints. So I want to see that animation work. So if there we go. We saw the animation. Cool. So we're getting there. And great. We get vectors not incrementable. Clearly, there's some problem with erasing from the vector, I think. So I'll have to debug a little bit here. Ignore, iterator, invalid parameter pass to. I may have to do this incrementing inside of the for loop. Yeah, okay. So we're going to do this. I think this will solve. The iterator was getting incremented in this portion of the for loop. If you're familiar with for loops, it contains 3 parts. And the 3 parts are broken up by a semicolon. The first part is where we initialize our incrementer or our iterator. The second part is the truth test to see whether or not we go inside of the for loop. So if we're not at the end of the container, the vector, then we go in. And then after the iteration is done, this component gets called, whatever's after this last semicolon. And that's where I was incrementing the iterator. The problem I think that occurred is we erased that baddie out of the iterator. And then we did our increment here, but the guy who the collision we occurred with was probably the bad guy at the very end of the container. Therefore, we did our loop thinking there was more, but we just erased the guy from the very end of the container. So if I do if it, or let's just say if pool end, if not end, if it isn't the end of the pool, so we're not at the end iterator, kind of like the same check we're doing here, then we'll increment the iterator here. I maybe could clean this up at some point. I think this will do the job for us though. That way, if we erase the last element in our pool vector, it won't get incremented there and it won't get incremented here. Therefore, we are at the end and we just exit out. I think that will fix our problem. Okay, so that fixes that problem. I'm trying to think of that animation issue. Why did the animation leave? That animation left that last frame of the explosion. What do I need to do to turf that? Do I need to destroy animate? I don't know. Let me just have a look here. Animate. We've run all of the actions. I could release it so it gets garbage collected, but that's not what I want. I want to destroy him. What do I do? Maybe I'll look at that in a bit. I don't want to sit here and debug because I'm a bit lost at how to get rid of that. And I know I'll figure it out, but I don't want to sit here and be Googling the solution and slowing up the stream. Okay, so let's just deal with that animation kind of stuck on the last frame. I'll figure it out. I mean, maybe I can destroy the sequence. Anyway, I'll figure it out. Okay. Okay, so we've got that. We're popping him off. The bad guy is gone. Okay, so where were we left? Now we want to do our game over condition. So if no, it's core. If core I will define core outside here so I can reference him. So get player, get hit points. Okay, great. So get hit points. If get hit points is less than or equal to 0, game over. So game over. So what do we want to do? I guess ideally I want to create another scene that just simply says game over. But for now, let's just go and open the game menu scene. So you basically lose and you go back to the starting menu. So we should be able to director, get instance. And from get instance, we can run with scene, or it's replace with scene because we already have a running scene. I think it's replace. Replace scene, perfect. And we want game menu. Unfortunately, game menu isn't referenced, so I can reference it. I'll just include it in here. So this, I'm just referencing the game menu class. And the game menu class, well, you'll see what it is in a second. It was just that scene with that big green button that said play. So we're just going to close down this scene, stop the scene, and open up, if I spell it right. Was it create? Create. And it returns back a scene. Okay, menu create. let me just go to here. Replace scene, game scene, scene create, add child. Perfect. And just like app delegate, this is basically, I'm going to copy the code I already added to run game menu scene. I guess it wasn't create, it was simply scene. So scene. So game over, we close the game layer scene down and we put the game menu scene back on. Let's see what that gives us. I might drop a breakpoint in here just so we know when it's occurred. Okay, so we've got an error. If pool.end. What does this return? Oh, if it is not equal to n. There we go. Okay, try this. Okay. So how long have we been streaming for? I've been streaming for approximately 2.5 hours. I think I'll probably stop after we get this game over condition working. And then we'll wrap it up tomorrow. I'm just getting a bit hungry here, so I'm fading. Okay, this is the game menu scene that we're going to replace, right? This is a scene just like the game layer is a scene, except all this guy has on it is a menu item, this button. So if we have the game over condition, then we just go back to the starting point and we can start the game over again. Tomorrow, though, what I want to do is we will... Interesting, something is not playing nice here. Everything is frozen. Quad command, resize. What is going on? Cannot find PDB file. I don't think that matters. I'm going to try running that again. Hopefully I didn't break something. Play. Let's have a look. What did I introduce? What bug did I introduce? Let's drop a breakpoint in init. See if we at least get to that. So we get into init. Where am I breaking? So we're adding our sprites, right? Our game background. Oh, our overlay. Remember the blood splatter, the goo splatter? Right? We're making it transparent, but as we take damage, we're going to... I believe this takes a full byte, so it's up to 255. So if I set it to 255, that will be fully shown. So all we have to do is in our when we take hit point damage, we can change our opacity here. Anyway, game layer, mouse move, dispatchers, schedule update. Maybe it's blowing up in shared core. Step over. Yeah, great. Auto release, whatever. So on new game, click. Scene create, game layer create, push on to scene. Where are we dying here? Replace scene, game scene. Game layer, game scene. Wonder if we even get into our update. Let us see. Just trying to think of where else I could have introduced a bug. Could be in core as well, but what did I do? I don't think I did anything in there. Let's just see. So step into, we're inside of something. I went a little too deep, but we'll get out of here. CC menu. So it's just destroying the menu item, button, I think. We'll step out of here. Let's get out of here. Event dispatcher. Let's get out of here. Come on. Come on. OpenGL view. Interesting. Let's just see. I want to see my call stacks. Where are my calls originating? Director, draw scene, main game loop, application run, and our main method. So we're not at all in any of our own code. Okay. Let's just get out of here. Come on. Come on. I'm okay with that. I'm okay with it. You know, I'm just going to continue. So we are getting to our update method. Where is he getting borked? So let me step over the player move because that seemed to work okay. Now update baddies. That was simply pushing new bad guys to the game. I don't think it's dying there. It seems like it's dying inside a handle collision. So let's loop through. I get the feeling me mucking around with that iterator is giving us the grief. So no collisions occurring. So it can't be that. But everything is frozen. What the heck? What am I doing? What am I doing? So bad guys are getting pushed. So we're adding the bad guys. Where did I have add bad guys? Pushback, window size, random location, set position, finite actions. I just am at loss. What did I add last? What the heck did I do? Okay, so let's look at baddie. I'm going to Control Z. What did I add? Control Y, animate. I don't think this is it though. Where would I have borked this? Where did I bork it? And set player moving false. We know we update. We know we handle collision. Oh, okay. So I am not updating the iterator. Okay. So it was just stuck in an infinite loop because we didn't update the iterator. So I can do, if I just need to move iterator pool n. Okay. That's what I did. I introduced an infinite loop here. So if I move this logic outside of this if statement, then I think we're good. Okay. Let's give it a shot. So I don't think we need to see that. And now we're back in action. I'm going to take some damage here. This guy's going to give me some damage. He's going to give me some damage. I just want to check. I want to check game layer. Where is our... Okay. So we are... Let's just F11 in to get hit points. Step into. I want to see how we're doing for hit points. So we've got no hit points. Let me just step in. Let's get it in scope. Pardon me, I've got 6 hit points. So we're slowly dropping dead. Okay, good thing is core has the get hit points. And now if hit points is less than this, let's do this. Else, let's start adding our overlay so that we can see some opacity on that. So where did we, our overlay is add child overlay. Let's give him a tag name so we can fetch him. Again, never hard code literal constant strings or any sort of value. So don't do what I just did. Let's check. So now let's say else. So let's just say I want to get HP. So let's go to core and actually get the hit points out. We want to... So let's just do this logic. So we know the hit points is 10. So if we take HP divided by 10 multiplied by 255, and I'll explain the logic in a second. I don't need to do precedence, but whatever. Auto... So this will, okay, so let's say we've got 5 hit points. So we're down, we've lost half our hit points. So 5 divided by 10. So I just want to do this on a calculator so we can see what's going on here. Okay, so 5 divided by 10 is 0.5. So we're down half our hit points. And then we multiply by 255. And the reason why we multiply by 255 is because the opacity is stored as a byte. So what does that mean? If we hover over set opacity, I'm not getting any IntelliSense, probably because we're running. I'm going to stop the game. So it takes a GLU byte, which is an unsigned OpenGL byte, which is the value of 0 to 255. So if we set our gross blood splatter overlay to 255, this will be fully shown. There'll be 0 transparency. If we set the opacity to 0, it's fully transparent. So by doing that logic here, if we're down half hit points and, you know, we do it through the calculator, we've got, you know, 5 divided by 10 because we've lost half our hit points, and we multiply it by 255, then this damage will store the value of the opacity that we should be setting. And as we take more damage, that overlay is going to get more pronounced, and it'll bother you, right? Like the fog of war, it'll get in your way of playing the game. So as you take damage, you know, you should have a bit of a crutch. So I need to get, though, that layer. I need to get that child overlay. with that tag, with that hard-coded string. So if I go this and get something by tag, get child by tag, here we go, get child by tag. And again, see, I'm spreading out that literal constant across two places, not a good idea. So get child by tag, what did I miss? Int, 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 oh. Okay, hold on. What did I miss here? That's his name. I guess tag is either an int or a string. Okay, well, let's leave it as a string and get it by, get child by name. I'm assuming it's name. Okay, overlay. Okay, so now we're getting child by, we can just go auto. It's really a sprite star, a pointer to sprite. Auto overlay is equal to, so we fetch the overlay, and now let's set his opacity to be the value of damage. Now that should slowly appear in the foreground as we take hits. So we've got the game over condition, which I haven't even tested yet. I hope we're good. And as we progressively take damage, we set the opacity. So I'm going to do an else if because I don't even want to do this if it's not less than 10, because 10 is full hit points. So we want that to display. Okay, let's give this a shot. I'm hoping this is going to look good. So we're good. No damage yet. So we should have taken a bit of damage. We're taking some damage here. I'm not too sure why we're not jumping into here. So get hit points. I left 10 over that. So we've got 8 hit points. Oh. What was my logic? What is the overflow? What is my overflow? Let's just stop this. There's just something goofy going on in my logic, I think. Or wait a minute. Let me just try it again. Hold on. I know there's a problem. I just want to see what. So let's take a bit of damage. Damage is 0. So we've got 9 divided by 10 multiplied by 255. What am I doing? Okay, let's stop. Int damage. Oh, so the problem is this needs to be a float. That needs to be interpreted as a float. Because if we truncate, let me just try this. And that should get cast to, let me just try this. Any day. It's trying to compile a game layer. What the heck? 9 divided by 10 times 255. What am I dropping? Am I considering that as an int? And if I go, And if I explicitly cast that to float because he'll be an int, will that do what I want? Maybe. Because I think what's going on here is we're using whole numbers, but we're actually doing division, which will leave remainders. So something is getting truncated. Let's just try this. I would approach this differently. I'm kind of rushing to get this showing, but let's see. So this is what we want. So I needed to explicitly use a floating point or a decimal point, because the division, if the division assumed this was an integer, like the outcome of this was an integer, then how this was always a fractional thing. Like, I'll just explain what happened. Let me go back. So remember we said if I had 5 hit points, we divide by 10. The outcome is 0.5. So we never have a whole number coming out of this this calculation. But if I explicitly say a float, then we do get that floating point value. If I don't say float explicitly, this will be converted to an int, and it will truncate any floating point, so it'll be 0. So this will always come out as 0. The only time it would come out as a whole number is if I didn't have this logic here, and HP was 10 divided by 10, then this would be 1, and we would get 255. Okay, anyway, I think my logic needs to be inverted, because let me look at this. We need to, 1 needs to be 0. Let me just try this. I may need to do a -10 on this to invert this logic. And let's just have a look. See how this is looking. So, okay, first off, the blood splatter, I need to set its anchor point to 0.5. Because you can see its anchor point is 0, so it's hanging out at the bottom. Let's just start taking some damage. And now it's getting more transparent. So I do need to do a -10. As I'm taking more damage, it's being less prevalent. You can see it's slowly going away. But I'm going to kill myself first because I want to test our game over condition. And then I'll fix the overlay magic. I think I probably only got 1 hit point left. Awesome. So we took all our hit points, we died, and the game just simply quit. We go back to play. Now I can't reinitialize a game. Clearly I've got a bit of an issue there, but it's something I can quickly tackle later. Okay, so what am I trying to do? So we need to do this. We're getting our magic here. And this is going to be a fractional. So for example, if we've got 7 hit points and we divide by 10, then we have 0.7. But we want to do this. 1.0f minus the outcome of this. So what this is going to do is this will invert. Remember how the transparency was it was becoming more transparent as I was taking damage? I want to kind of invert that so that it's the opposite, and which is what we expect. So let's try this now. So once I get this done, I think I'm going to bail for the afternoon. Make sure you guys follow me, and you can watch some more. I want to do some blockchain stuff, code some blockchain. Do a little bit of like what is blockchain and Bitcoin and how to actually code a blockchain and like how it works. It seems like it's kind of an interesting thing right now. So, okay, let's start taking some damage. So can we sort of see? I can sort of see. I don't think you guys will be able to see the blood splatters, but see, you're starting to see it as you take more damage. So, yeah, the logic is working. I need to definitely add the logic though, where if the bad guy is of the same color, we actually gain points. It's actually quite a bit more to this game. I just don't have, just based on the time, I wasn't really able to do everything. Like for example, if we look at our game sprites, I want to add the power-ups, right? You get plus 100 points. This power-up creates a bomb and it explodes all the cells in a certain radius. This power-up changes your color. So you randomly change to a different color. The timer slows down time. So you're fast, but everyone else is slow. The heal is the red cross. And the yellow lightning bolt is you go fast, everybody else stays the same speed. So I want to do that, but I might just jump ahead a bit and kind of have some of the game done and then go through the code instead of coding it. Anyway, so what's the last thing I want to do before I bail out of here? I want to make sure the overlay is in the middle of the screen. So the overlay doesn't really look good right now. I need to set its anchor point to a vec2, to a point, and it's 0.5, which means the middle of the screen and the middle of the screen. And we want that to be a float. So we should also do that with our background. It should be centered in the middle. I know the game is really small right now. I've got it set to such a small dimension. And once we make our game full screen, this background will look weird. Right now, it's such a huge image that it doesn't look weird, but I want to center it in the middle so when we increase the size of our window, it looks good. So we are basically putting everything in the exact center of the screen. Okay, let's run the game one more time. Okay, hurry up. Let's go. Okay, now let's start taking some damage. Oh, it didn't seem to center for me. Let's just see. What did I do? Yeah, like I'm expecting to see the splatter more in the center. I'll have to look. Anyway, it'll be something I'll fix tonight, and it'll be all done for tomorrow's broadcast. I'll probably do one more day of Cocos2d-x game. Then, so tomorrow is going to be, what day is today? Wednesday. So tomorrow, Thursday, one more day. Friday, maybe blockchain, or back to C++ training. Anyway, guys, you know what? That's it for tonight. Remember, if you look on my home screen, Twitch, not my dashboard, but my front screen. I'll upload the source code later on. There's already some of the source code from previous streams. Where's right there? So the link is on my Twitch homepage. Awesome. Anyway, guys, since there's no further questions, I am going to bail out for the day. I'll be back tomorrow at about 10 a.m. Mountain Time, and hope to see you then. Thanks, guys.